Howdy folks, welcome to Punnet Squares, AP Bio Style. Now before we get into how to use Punnet Squares, we're going to review what Punnet Squares are and how to do them. So what you see in front of you is an example of a Punnet Square problem that you might have seen in 9th grade biology. It's asking you to find the percent offspring from the following cross: a brown turtle and a green turtle. Now we're going to use B as the color, and you'll notice that one of these letters is capitalized. This indicates that it is the dominant color. So brown is dominant over the green. And because the brown colored turtle has a capital and a lowercase letter indicated, this is known as the heterozygous condition. For the green turtle, they are both lowercase, so this is called homozygous recessive. Now what we're going to do is we are going to calculate the percent offspring based on their phenotype. The phenotype would be what they physically look like. So for example, even though this turtle is heterozygous, that's its genotype, its phenotype is the color of the turtle. That's what it looks like. So to do this problem, I'm going to take the alleles of this first turtle and I'm going to place it either on this section of my Punnet square or this section here. It doesn't matter which. And then for the other turtle, I'm going to place it on the other axis. Now, when I cross these, what I'm going to do is bring the capital letter, or this letter here, into each of these boxes. And I'm going to bring this letter here into each of these boxes. Next, I'll take this letter here and place it into each of these boxes. And I'll take this letter here and place it into each of these boxes. So I have filled out the chi-square table with the prediction of what these offspring are going to be. You'll notice that two of them have capital letter B, and two of them have only lowercase b. So when I find the percent offspring for the following cross, and I'm looking for the phenotype, this capital B will automatically make these babies brown in color, and the fact that these are two lowercase b's will make these babies green in color. So 2 out of the 4, or 50%, are brown, and 2 out of the 4, or 50%, will be green. Now I'm going to show you how we are going to change this slightly for AP Biology. We're not going to change the Punnet square in the prediction part. This part remains the same, but we're going to do something different after this point. So we have the same information. A heterozygous brown sea turtle mates with a green recessive turtle and produced 183 eggs. The following offspring are observed. And you can see on this table that they give you the offspring itself. Perform a chi-square to see if the traits follow traditional Mendelian genetics. So this is a great example of how 9th grade biology, or AP biology, is different than 9th grade. Whereas before, all you had to do was calculate the number or percentage. Now we're going to see, do those numbers, or do the number of actual offspring follow Mendelian genetics? In other words, do we get out, or do we get close to a 50-50 percentage just like we expect? So let's start with our null hypothesis. The null hypothesis is that the offspring follow that traditional Mendelian genetics. And that's what we did on the previous slide. We calculated what those percentages should be. The alternative hypothesis is that the offspring do not follow Mendelian genetics. Now at this point in the lesson, all we have to do is state whether or not they follow Mendelian genetics. If we find that they don't, we're going to learn reasons why they would not follow traditional Mendelian genetics. So I have quickly drawn a chi-square table using my Unit 1 notebook as a reference. I feel like this table helps me to organize my thoughts and make sure I'm doing all the steps correctly. First, I'm going to place each of the characteristics on the left column. Luckily, there's only 2. My options are brown, and green. Next is the tricky part. Next is the expected values. And many students forget how to get the expected values. You need to remember that the expected values are driven by the null hypothesis. In this case, the null hypothesis was that the offspring followed traditional Mendelian genetics. In other words, the percentages we got from the Punnett square when we started this problem is going to help us drive what we are looking for in the expected value. According to the prompt, the turtles had 183 eggs. And based on the Punnett square that we did, we expect that 50% of them would be brown. So to calculate that, I'm going to do 183 times 50%, and that will give me the expected value for brown. My number came out to a decimal, and that's okay. Expected values can have decimals. To get the green color, or the green percentage, of the green expected value, I'm going to do the same thing. 183 times that 50% would be, we're expecting 91.5 to be green. And remember, this 50% came from the Punnett square we did at the start of this video. Now I'm going to go ahead and fill in my expected values. And I'm going to get the observed values from the table on the previous slide. In other words, the observed value is the actual babies that were born. Again, these numbers came from the table that we were given. 114 babies were born brown, 69 babies were born green. Now we do expect variation in or a little bit of randomness in the babies that are born. But what we need to check is this randomness too far away from what is the expected value? So I'm going to fill out the rest of the table with the observed minus the expected, the observed minus the expected, and then I'm going to square that value. And pay close attention to where this square is. That means that this value right here, even though it was negative 22.5 times negative 22.5 comes out to a positive value. There should be no negative values in this column ever. And now I'm going to fill out the last column, which is the observed minus the expected squared divided by the expected. Now to determine my chi-square, I'm going to take this last column and add it up, and that value, when I add up these two numbers here, that value is going to be my chi-square. Now to determine whether or not we reject or fail to reject the null hypothesis, I need information from the chi-square table College Board has provided for us. I'm going to compare the critical value to this chi-square. In order to figure out what the critical value is, I need to know the degrees of freedom. The degrees of freedom are equal to 1. Therefore, my critical value is, based on this information, I would reject the null hypothesis. Reject the null hypothesis because at 1 degree of freedom and p equals 0.05, the chi-square of 11.07 is larger than the critical value of 3.84. Thanks y'all so much for watching. I hope this helped.